The Wrench and the Panzer. How Maintenance Won the Tank War. They found it on a Tuesday morning in March 1945, sitting in a farmer's field 30 miles east of the Rhine. The Panther tank looked magnificent even in defeat, 60 tons of sloped armor and engineering precision, its long 75mm gun still pointing defiantly toward the western horizon. The paint was barely scratched. The tracks appeared intact. There were no obvious signs of combat damage, no shell holes punched through its glacis plate, no blackened scorch marks from internal fire. Staff Sergeant Raymond Buckley, of the 3rd Armored Division's maintenance company, walked around the abandoned German tank with professional curiosity. He'd seen dozens of knocked-out Panthers by this point in the war, but most had been thoroughly destroyed, turrets blown off, holes cracked open like tin cans, clear evidence of violent death. This one looked like its crew had simply parked it and walked away. "Check for booby traps," Buckley called to his team. They'd learned that lesson the hard way in France. But after a careful inspection, they found nothing. No tripwires, no hidden explosives, no nasty surprises. The Panther was simply there, waiting. Buckley climbed up on the hull and peered through the commander's hatch. The interior was immaculate. The gun breech gleamed. Ammunition racks were still half full. The leather seats showed normal wear but no damage. He could smell oil and cordite and the faint residue of human occupation, sweat, cigarette smoke, fear. But there was no blood, no sign of panic or hasty evacuation. "Sir, you're gonna want to see this," called Corporal Jimmy Martinez from the rear of the tank. He was standing by the massive engine compartment, inspection plate open, looking down into the mechanical guts of the Maybach HL 230 engine. Buckley climbed down and joined him. Martinez pointed with his flashlight into the engine bay. "Final drives seized up. Looks like the left side transmission gave out completely. And see those burns on the manifold? Engine's been running hot for a while. I'd bet money there's cracked cylinder heads in there." "Could it be repaired?" Buckley asked. Martinez laughed, not unkindly. "Sir, if we were in Detroit with a full machine shop and 3 weeks, maybe. Out here?" He shook his head. "This thing's a write-off. The crew knew it, too. That's why they walked." And that's when Sergeant Buckley began to understand something that would fundamentally change how he thought about armored warfare. The Panther, one of the most feared tanks in the German arsenal, a machine that could kill a Sherman from 2,000 yards, had been defeated not by American guns, but by its own complexity. It had broken down, and broken down so catastrophically that even its own crew couldn't fix it in the field. Over the next few weeks, as American forces drove deeper into Germany, Buckley's maintenance company would see this pattern repeat itself again and again. Powerful German tanks, abandoned not because they'd been destroyed in combat, but because they'd simply stopped working and couldn't be repaired quickly enough to matter. This is the story they never tell in the war movies. Not the story of heroic tank duels or dramatic last stands, but the unglamorous truth about why America won the armored war in Europe. It wasn't because the Sherman was a better tank than the Panther by most measures. It wasn't. It was because when a Sherman broke down, an average crew could fix it in a field using basic tools and get back into the fight. When a Panther broke down, it was done. The education of an ordnance officer. Captain Theodore Haussmann had never expected to spend World War II thinking about ball bearings and transmission gears, but war has a way of scrambling everyone's expectations. In civilian life, he'd been an engineer at General Motors, designing commercial truck components. Now he was an ordnance officer with the 9th Armored Division, responsible for keeping dozens of Sherman tanks running under combat conditions. His education in the realities of tank maintenance began in earnest during the Battle of the Bulge in December 1944. The German offensive had caught American forces off guard, and Haussmann's division had been rushed north to help contain the breakthrough. For 2 weeks, his maintenance crews worked around the clock in sub-zero temperatures, repairing battle damage and fixing mechanical failures. What surprised Haussmann wasn't how many tanks broke down that was expected in winter combat. What surprised him was how quickly his crews could get them running again. A Sherman with a thrown track could be mobile again in an hour. One with a damaged final drive might take 4 hours. Even a tank with a blown engine could be back in action within 24 hours if they had the right replacement parts, which they usually did. The American supply system had prioritized modularity. Sherman tanks used engines derived from commercial truck, could be mobile again in an hour. One with a damaged final drive might take 4 hours. Even a tank with a blown engine could be back in action within 24 hours if they had the right replacement parts, which they usually did. The American supply system had prioritized modularity. Sherman tanks used engines derived from commercial truck designs, literally, in some cases, the same engines that powered Greyhound buses and GMC trucks back home. The Ford GAA engine, the Continental Radial, the Chrysler Multibank, all were based on proven civilian technologies that thousands of American mechanics already understood. Parts were manufactured in massive quantities and shipped forward in standardized packages. A maintenance company could swap out an entire engine assembly in a day. But it was after the bulge ended, as American forces resumed their advance into Germany, that Houseman truly began to appreciate the American approach to tank design. Because that's when his crews started examining captured German vehicles. And what they found was both impressive and horrifying. First contact, the Tiger. The first German tank that Houseman's unit captured intact was a Tiger I, the legendary heavy tank that American tankers had learned to fear. It had been abandoned in a village outside St. Vith, apparently immobilized by mechanical failure rather than combat damage. "Jesus Christ, look at the size of this thing," Martinez said, running his hand along the massive frontal armor. The Tiger stood nearly 10 feet tall, its boxy hull radiating menace even in stillness. The 88mm gun looked like it could punch through a building. Houseman ordered his best mechanics to conduct a thorough inspection. What they discovered was a masterpiece of engineering that was also a maintenance nightmare. The Tiger weighed 56 tons, nearly twice the weight of a Sherman. Its Maybach HL 230 P45 engine produced 700 horsepower. Impressive on paper, but it was essentially a high-performance racing engine adapted for tank use. The transmission was a complex 8-speed Maybach Alvarez hydraulic pre-selector system, a technological marvel that required specialized knowledge to maintain. "Sir, come look at this," called Sergeant Willie Thompson, one of Houseman's most experienced mechanics. Thompson had been a diesel mechanic in Louisiana before the war and had an almost supernatural ability to diagnose engine problems by sound alone. Houseman climbed into the Tiger's engine compartment, which was surprisingly cramped given the tank's massive size. Thompson pointed to the final drive assembly. "See how they've got it set up? The transmission's in the front, connected to the engine in the back by this long drive shaft running under the turret basket. Everything's packed in tight. Now look at how many specialized fasteners they're using. These aren't standard bolts. Each one needs a specific tool." Thompson picked up a German tool roll they'd found in the tank. The crew carried maybe 30 different specialized tools just for routine maintenance. Compare that to a Sherman. We can do most repairs with a standard socket set and some wrenches. They spent the next 2 days trying to start the Tiger. The battery was dead, but they had American batteries they could adapt. The fuel system seemed intact, though the fuel filters were clogged. The biggest problem was the engine itself, which had thrown a timing gear. In a Sherman, replacing a timing gear was a 4-hour job. In the Tiger, they'd have to disassemble half the engine to even access it. "How long to fix this properly?" Houseman asked. Thompson wiped his hands on a rag. "In a full maintenance depot with German parts and specialized tools, maybe a week. Out here, sir, I'm not sure we could fix it at all. And even if we did, how long until something else breaks? These things are supposed to go back for major maintenance every 500 miles. We've been pushing Shermans for 2,000 miles between overhauls." That was the moment Houseman began to understand the fundamental difference in design philosophy. The Germans had built their tanks to perform brilliantly, and they did. But they built them without adequate consideration for field maintenance, battlefield repairs, or the realities of extended operations far from fully equipped workshops. American tanks, by contrast, had been designed from the ground up to be maintainable under primitive conditions. Every major component could be removed and replaced with basic tools. Parts were standardized across different models. The engines were simple and robust rather than sophisticated and temperamental. It wasn't exciting engineering, but it was smart engineering. The Panthers' secret weakness. By April 1945, Houseman's maintenance company had examined dozens of captured German tanks. They'd seen Tigers, Panthers, Panzer IVs, and various tank destroyers. Each examination reinforced the same pattern. German tanks were marvels of engineering that were fantastically difficult to keep running. The Panther was perhaps the most revealing case. On paper, it was the best all-around tank of the war. Its sloped armor provided excellent protection while keeping weight down. Its 75mm Keg 42 gun could penetrate any Allied tank from extreme range. It had better mobility than the Tiger, with a maximum speed of 34 miles per hour. German crews loved it. American tankers feared it. But the Panther had a fatal flaw that no amount of armor or firepower could compensate for. It was mechanically unreliable and extraordinarily difficult to maintain in the field. Houseman's unit captured their first drivable Panther in mid-April. Unlike the previous abandoned tanks they'd examined, this one was in running condition. The crew had surrendered rather than abandoned it. Houseman decided to conduct an experiment. They'd use the Panther for 3 days of normal operations and document every maintenance requirement. They assigned it to Sergeant Buckley, who'd proven capable of nursing any vehicle through difficult conditions. Just drive it like you'd drive a Sherman, Houseman instructed. Normal operations, nothing too demanding. Keep notes on everything. The experiment was enlightening in all the wrong ways. Day 1. The Panther ran well for the first few hours. Buckley reported that the tank was smooth, powerful, and the controls were reasonably intuitive once you got used to the German layout. But after 30 miles of mixed road and cross-country travel, they had to stop for an unscheduled maintenance check. The final drives were running hot, a known Panther problem. The crew had to let them cool down for 2 hours. In a Sherman, we'd just keep going, Buckley noted in his report. The final drives might run warm, but they don't overheat in normal operation. Day 2. The Panther developed an oil leak from the transmission. Not catastrophic, but concerning. They topped up the oil and continued. By mid-afternoon, the engine began running rough. Thompson diagnosed it as a fuel delivery problem. One of the fuel injection nozzles was partially clogged. In a Sherman's carbureted engine, they could clean it in minutes. The Panther's sophisticated injection system required careful disassembly and specialized knowledge. They spent 3 hours on the repair. Day 3. The left track through a connector link. This was supposed to be a routine repair every tank through tracks occasionally. But the Panther's overlapping road wheel design meant they had to remove 3 road wheels just to access the track. What would be a 30-minute repair on a Sherman took 4 hours on the Panther. "Sir, I've had enough," Buckley reported that evening. "This thing's a widowmaker. It's not the crew that'll kill you, it's the goddamn maintenance. We spent more time fixing this tank than fighting it." Houseman compiled a detailed report. Comparative maintenance requirements. Sherman versus Panther. Track repair. 30 to 45 minutes average. Panther. 3 to 4 hours average due to overlapping road wheels. Engine access. Remove rear hull plate. 15 minutes with 2 men. Panther remove multiple access panels. Disconnect numerous systems. 45 plus minutes. Oil change. 30 minutes. Panther 1.5 hours requires removal of multiple skirt plates. Final drive repair. Remove final drive housing. 3 to 4 hours. Panther, remove road wheels, skirt plates, then final drive. 8 to 10 hours. Mean miles between failures. Approximately 1,200 miles height. Panther, German data, 150 miles initial production, improved to 800 miles later. That last statistic was the most damning. Even late production Panthers required major maintenance after 800 miles, and many components failed far sooner. The final drives, which had to handle the tank's 45-ton weight, were particularly problematic. German maintenance records captured later in the war showed that Panthers frequently required final drive replacement after just 150 miles of operation. By contrast, Sherman final drives could last 2,000 miles or more. They were simpler, overbuilt, and based on truck components that had been perfected over decades of civilian use. The numbers tell the story. As the war wound down in late April and early May 1945, the U.S. Army's Ordnance Department compiled comprehensive data on German tank maintenance. The numbers revealed a stark picture of the German armored forces' hidden weakness. German tank availability rates. German Army data, 1,944. Panther, 37% combat ready on average. Tiger 1, 42% combat ready on average. Tiger 2, 32% combat ready on average. Panzer 4, 62% combat ready on average. American tank availability rates. U.S. Army data, 1,944 to 1,945. Sherman, 74% combat ready on average. M10, tank destroyer, 71% combat ready. M18 Hellcat, 77% combat ready. The difference was staggering. On any given day, a German panzer division with 100 Panthers on its roster could field maybe 37 operational tanks. An American armored division with 100 Shermans could field 74. The implications were profound. Germany's tactical advantage in tank quality was being eroded by terrible operational readiness. A Panther might be able to kill a Sherman from 2,000 yards, but that advantage meant nothing if the Panther was sitting in a workshop awaiting parts and specialized maintenance. The situation was even worse for the Tiger tanks. Each Tiger company required a massive logistical tail, specialized recovery vehicles, workshops, spare parts, and highly trained mechanics. A Tiger company of 14 tanks required nearly as many support personnel as an entire panzer battalion of Panzer IVs. American interrogators captured German maintenance officers who painted a picture of desperation. One German captain, formerly responsible for maintaining a Panther battalion, described the situation in late 1944. "We received new Panthers in November 1944. Beautiful machines, powerful, well-armed. Within 2 weeks, half were deadlined for maintenance. Final drive failures, mostly. We had the parts, but each repair took our best mechanics 3 days of work. By December, we were lucky to have 8 operational tanks out of 44 on our roster." The worst part was watching American tanks in the distance. They moved constantly, always maneuvering. Our Panthers, when they ran, were superior in combat, but they ran so rarely. We'd get them repaired, send them into action, and within days they'd be back in the workshop. It was maddening. Another German officer, a maintenance battalion commander, was even more blunt. "We lost the war in the workshops. For every Panther destroyed in combat, 3 were lost to mechanical failure. And those weren't even losses, they were just unavailable, waiting for parts or repairs that never came." By 1945, we had hundreds of Panthers sitting in depots, awaiting repairs we couldn't complete because we lacked parts, tools, or trained mechanics. The Americans could afford to lose tanks in battle because they could replace them. We couldn't afford our tanks to break down, but they did, constantly. The design philosophy gap. As American engineers examined, captured German tanks in detail, a clear pattern emerged in design philosophy that explained the maintenance differences. German design priorities. Maximum performance. Sophisticated technology. Precision engineering. Protection and firepower. Far down the list. Ease of maintenance. American design priorities. Reliability. Ease of production. Maintainability. Adequate performance. Use of proven technology. Neither approach was inherently wrong, but each reflected different strategic realities. Germany had developed its tanks expecting short, decisive campaigns. The Blitzkrieg doctrine assumed rapid victories where tanks would penetrate deep into enemy territory, but would be close enough to Germany for sophisticated maintenance infrastructure to support them. The early war proved this model. In Poland, France, and the early Soviet campaign, German tanks performed brilliantly. But after 1942, as the war became a grinding attritional struggle, the German maintenance burden became crushing. Panthers operating deep in Russia or in the hedgerows of France couldn't easily return to Germany for depot-level maintenance. Frontline workshops lacked the specialized tools and trained personnel needed to repair sophisticated German components. Tanks broke down and sat, waiting for parts that were stuck in a supply system under constant attack from Allied aircraft. American designers, by contrast, had planned from the start for sustained operations far from home. Every Sherman component was designed with field maintenance in mind. The Continental radial engine was based on an aircraft engine proven, reliable, powerful enough. Could a more sophisticated engine have produced more power? Certainly. But the Continental could be rebuilt by any competent mechanic, with basic tools, and that mattered more than theoretical performance. The same philosophy extended to every system. The Sherman's vertical volatile spring suspension, VVSS, wasn't as sophisticated as the Panthers' torsion bar system, but it was far easier to repair. The Sherman's rubber block tracks wore out faster than German metal tracks, but they could be replaced in under an hour. The Sherman's transmission was straightforward and robust, while the Panthers' transmission was a precision instrument that required expert knowledge. Captain Hausmann put it succinctly in a report to his superiors. The Germans built tanks to win battles. We built tanks to win a war. There's a difference. The testimony of the wrenches. By VE Day in May 1945, Hausmann's maintenance company had accumulated a wealth of practical knowledge about German tanks. Much of it came not from formal testing, but from the day-to-day experiences of mechanics who'd actually tried to keep German vehicles running. Sergeant Thompson summarized the Panther experience. It's like they designed it without ever asking a mechanic what he thought. Everything's accessible, but barely. You can get to the engine, but only after removing 6 panels and disconnecting 8 systems. The fuel filters are in a stupid location. The oil drain plug requires a special wrench. The road wheels, don't get me started on those overlapping road wheels. Sure, they distribute weight nicely, but try changing one in the mud. You'll be there for hours. Corporal Martinez described working on a Tiger. The engineering is impressive, no question. Everything's precisely machined, perfectly fitted. But precise means tight tolerances, and tight tolerances mean things bind up when they get dirty or damaged. A Sherman can take abuse, you can bang on it with a hammer, force things a bit, make field expedient repairs. You try that with a Tiger, you'll break something expensive and irreplaceable. Sergeant Buckley, who'd driven both Panthers and Shermans, offered the tanker's perspective. When I'm in a Sherman and I hear a weird noise, I think, I'll get that checked when we stop. When I heard a weird noise in the Panther, I thought, oh God, what broke now? That's the difference. The Sherman's forgiving. The Panther's not. The maintenance troops' experience was backed up by hard data. American ordnance officers compiled statistics from maintenance logs. Average maintenance hours per 100 miles of operation. Inst of the tenor, 7 inst of days, 3.2 hours. Panther, 11.4 hours. Tiger 1, 17.8 hours. These figures included everything: routine maintenance, minor repairs, parts replacement, and diagnostic work. The message was clear. German tanks required 3 to 5 times as much maintenance effort as American tanks for the same amount of operation. The specialization requirement was even more pronounced. A Sherman could be maintained by mechanics with general automotive knowledge. German tanks required specialists who understood their specific systems. This created a training bottleneck. Germany couldn't produce enough trained mechanics to maintain their complex tanks, especially as the war progressed and experienced personnel were killed or wounded. The cascading failures. The maintenance burden had cascading effects throughout the German armored forces. Each broken-down tank tied up resources, recovery vehicles to tow it, workshops to repair it, guards to protect it, and logistics to supply parts. As the war progressed and Allied bombing disrupted German industry and transportation, these cascading effects became crippling. A captured German logistics officer described the situation in early 1945. We had a Panther battalion with 38 tanks assigned. On a good day, we could field 12 operational tanks. The other 26 were distributed across various maintenance states. 8 were awaiting major repairs, final drive failures, engine replacements. 7 needed medium repairs, suspension work, transmission service. 6 were awaiting parts that didn't exist anymore because the factory had been bombed. 5 were technically operational but had been cannibalized for parts to keep other tanks running. Our maintenance company had the manpower and skills to repair perhaps 3 or 4 tanks per week. If we had parts, we didn't have parts. So the tanks just sat, waiting, while their crews trained on foot or were reassigned to infantry duties. It was absurd we had magnificent tanks that couldn't fight because we couldn't maintain them. The parts shortage was particularly acute. German tanks used many proprietary components that couldn't be improvised or substituted. A Panther needed Maybach engine parts, made by Maybach. A Sherman could use parts from multiple manufacturers: Ford, Continental, Chrysler, General Motors, all building to similar specifications. When Allied bombing hit German industrial centers in 1944, it didn't just destroy tanks on assembly lines, it destroyed the parts supply chain. Without replacement final drives, Panthers became immobile. Without replacement road wheel bearings, Tigers sat idle. Without replacement fuel injection components, powerful Maybach engines were rendered useless. American mechanics, by contrast, could improvise. They welded broken parts, machined replacements from raw stock, cannibalized wrecked tanks for components, and even adapted civilian truck parts to military use. The Sherman's modular, standardized design made this possible. The Panther's specialized design made it nearly impossible. One American maintenance officer, surveying a German tank depot in May 1945, counted 67 Panthers and 23 Tigers awaiting repairs. With American resources and American parts, he wrote in his report, we could have maybe 10 of these Panthers operational within a month. With German resources in 1945, I doubt they could have repaired a single one. The battle that wasn't fought. Perhaps the most revealing maintenance story came not from a battle, but from a carefully controlled experiment conducted in June 1945, after the war's end. With hostilities over, the U.S. Army Ordnance Department organized a comprehensive trial. They would take 10 captured Panthers, all in good mechanical condition, and 10 Shermans from frontline units, and operate them side by side for 1,000 miles under identical conditions. The goal was to document exactly what maintaining German tanks actually required compared to American equivalents. The trial was conducted in southern Germany, using captured fuel and ammunition to ensure fair conditions. Each tank was assigned a crew of experienced soldiers, American crews for the Shermans, German POWs who volunteered for the Panthers. Each tank had an accompanying maintenance team with access to full parts inventories. The results were sobering. After 250 miles, Shermans, 8 operational, 2 undergoing routine maintenance. Panthers, 6 operational, 3 undergoing unscheduled repairs, 1 deadlined with final drive failure. After 500 miles, Shermans, 9 operational, 1 undergoing engine change. Panthers, 4 operational, 4 undergoing various repairs, 2 permanently deadlined. After 750 miles, Shermans, 8 operational, 2 undergoing scheduled maintenance. Panthers, 3 operational, 4 undergoing repairs, 3 permanently deadlined, parts unavailable. After 1,000 miles, Shermans, 7 operational, 2 undergoing maintenance, 1 deadlined requiring depot-level work. Panthers, 2 operational, 2 undergoing repairs, 6 permanently deadlined. The trial was terminated at 1,000 miles because there weren't enough operational Panthers to continue. Of the 10 Panthers that started the trial in good condition, only 2 remained operational. 6 had suffered mechanical failures that couldn't be repaired even with full parts availability. 2 were undergoing repairs that would take weeks to complete. Of the 10 Shermans, 7 were still operational, 2 were undergoing routine maintenance, and 1 needed depot-level engine work that would take a few days. The maintenance logs told the detailed story. The Panthers had suffered 47 mechanical failures requiring repair, 11 final drive failures, 8 track suspension failures, 7 engine problems, 6 transmission issues, and 15 miscellaneous component failures. The Shermans had 18 failures, 5 track, suspension issues, 4 minor engine problems, 3 electrical issues, and 6 miscellaneous problems. More significantly, the average repair time per failure was dramatically different. Panthers 18.7 hours average repair time per failure. Shermans 4.2 hours average repair time per failure. Even when both tanks experienced similar problems thrown tracks, for example, the Sherman was vastly easier to repair quickly. The German mechanics participating in the trial were candid in their assessments. One former Panther commander said, "This is why we lost. Not tactics, not training, not courage. Our tanks betrayed us by breaking down. Your tanks were your partners. They kept running." The Soviet comparison. It's worth noting that the Soviet approach to tank maintenance differed from both the American and German models, and offers an interesting counterpoint. Soviet T-34 tanks were even more austere than Shermans in terms of crew comfort and sophisticated systems, but they were also remarkably robust and simple to maintain. Soviet designers prioritized functionality over refinement. If a component worked adequately, that was good enough, no need to make it perfect. The T-34's Christie suspension was simple and reliable. Its diesel engine was crude but powerful. Its transmission was rough and difficult to operate, but mechanically straightforward to repair. Soviet maintenance doctrine assumed that most repairs would be conducted by conscript soldiers with minimal training, so everything was designed to be obvious and brutish. American maintenance personnel who examined T-34 seconds after the war noted that they lacked the refinement of American tanks, but shared the American emphasis on maintainability. A T-34 might not be as comfortable or as precisely manufactured as a Sherman, but a Russian mechanic with a hammer and basic wrenches could keep it running. The Germans, positioned between the American emphasis on sophisticated maintainability and the Soviet emphasis on brutal simplicity, had somehow chosen the worst of both approaches. Sophisticated complexity without adequate provision for field maintenance. The long-term implications. The maintenance lessons learned from World War II tank operations influenced American armored vehicle design for decades afterward. When the Army developed the M26 Pershing heavy tank in late 1944, early models suffered from reliability problems, similar to German tanks, complex powertrains, specialized components, high maintenance requirements. The Army quickly redesigned the vehicle, simplifying many systems and incorporating lessons learned from both Sherman successes and German failures. The M46, M47, and M48 tanks that followed continued this evolution. Each prioritized maintainability alongside performance. The M48, for instance, used a Continental AV-1790 engine that was powerful and sophisticated, but was also designed to be removed and replaced as a complete unit in under 2 hours by a trained crew. The entire power pack engine, transmission, final drives could be pulled out the back of the tank, a new one installed, and the tank returned to service in less than a day. This contrasted with contemporary Soviet tanks, where engine replacement often required removing the turret, and it was light years ahead of German World War II practice, where major repairs meant weeks in a workshop. The M60 and M1 Abrams continued the American emphasis on maintainability. The Abrams, despite being perhaps the most sophisticated tank in the world, can have its entire power pack removed and replaced in 30 minutes under field conditions. This isn't an accident, it's a design philosophy that traces directly back to lessons learned from German tank maintenance failures in World War II. The human cost. It's easy to get lost in statistics and engineering details, but the maintenance crisis had a profound human cost for German soldiers. Tank crews lived in constant anxiety about mechanical failure. Would the final drives hold for one more mission? Would the transmission last another day? Would the engine overheat again? This mechanical unreliability translated directly into tactical vulnerability. A tank that might break down at any moment couldn't be used aggressively. Commanders had to husband their operational tanks carefully, knowing that each one that broke down might not return to service for weeks, if ever. German tank commanders in interviews after the war repeatedly mentioned the psychological burden of unreliability. One Panther commander described it: "Every time I heard a strange noise, I felt sick to my stomach. Because I knew what it meant, we'd be stranded, waiting for recovery, watching the enemy advance while we sat helpless. Better to be destroyed in combat than to break down. At least that felt honorable." The maintenance burden also fell heavily on German mechanics, who worked desperately to keep tanks running under increasingly impossible conditions. These men, often older soldiers or those recovering from wounds, performed miracles of improvisation and dedication, but they couldn't overcome fundamental design flaws and parts shortages. A German maintenance sergeant captured in April 1945 spoke with evident frustration. "We knew how to fix anything. We were good mechanics. But we needed parts we didn't have, tools that were lost, time we weren't given. We'd work through the night repairing a Panther, send it back to the line, and it would return broken 2 days later. It was Sisyphean. We could never get ahead of the failures." For American tank crews, by contrast, maintenance was a routine inconvenience rather than an existential threat. Shermans broke down, certainly, but the breakdowns were manageable. Crews trusted that their maintenance teams could fix problems quickly and get them back into action. This psychological difference, trust versus anxiety, affected combat effectiveness in subtle but real ways. American tankers could focus on the enemy. German tankers had to worry about both the enemy and their own vehicles betraying them. The arithmetic of attrition. By late 1944, the maintenance differential had created a crisis for Germany that no amount of tactical skill could overcome. The arithmetic was brutal. Germany produced approximately 6,000 Panthers during the war. Sounds impressive, until you realize that at any given time, fewer than 40% were operational. So Germany's 6,000 Panthers effectively fielded about 2,400 tanks. America produced approximately 50,000 Shermans. With a 74% operational rate, that meant about 37,000 effective tanks, a ratio of more than 15 to 1. But the numbers were actually worse for Germany because of the maintenance tail. Each operational Panther required extensive logistics, support, recovery vehicles, workshop facilities, spare parts, stockpiles, trained mechanics. Germany's industrial capacity was already strained to the breaking point by 1944. Dedicating scarce resources to maintain complex tanks meant less capacity for other weapons production. The Americans, with more reliable tanks requiring less maintenance support, could focus their industrial might on production rather than repair. Sherman maintenance required fewer man-hours, fewer specialized parts, and less sophisticated facilities. This freed up resources for artillery, aircraft, trucks, and the 1,000 other tools of modern war. A German armored division in 1944 required nearly 30% of its manpower dedicated to maintenance and logistics functions. An American armored division needed less than 20% for the same functions. That meant the German division had fewer actual combat soldiers despite similar overall manpower. One American logistics officer calculated that supporting a German Panther battalion consumed roughly the same resources as supporting an American Sherman regiment 3 times as many tanks. If the Germans had built reliable tanks, he wrote, they could have effectively tripled their armored strength with the same industrial base. Instead, they built maintenance nightmares. The end of the maintenance war. In the final weeks of the war, as American forces pushed through southern Germany, maintenance companies like Hausmann's encountered thousands of abandoned German tanks. Most were not destroyed by combat, but by mechanical failure and lack of parts to repair them. Near Munich, they found a depot with 127 Panthers in various states of disrepair. Some needed minor work, a few hours of maintenance to return to service. Others were completely non-functional, cannibalized for parts to keep other tanks running. All were abandoned when the parts supply dried up completely. An American tank maintenance officer surveying the depot wrote, "These are magnificent machines betrayed by their own complexity. In another war, under different conditions, they might have been decisive. In this war, under these conditions, they were expensive paperweights. Staff Sergeant Buckley, who'd begun the journey by discovering that abandoned panther in a French field, walked through the Munich depot with a mixture of professional admiration and tactical satisfaction. "Part of me wants to be impressed," he told Captain Houseman. "These are beautiful tanks. But mostly I'm grateful we didn't build tanks like this. Because if we had, we'd have lost." The maintenance war had been won by the side that understood that reliability trumps performance, that simplicity beats sophistication, and that a running tank beats a broken superweapon every single time. Epilogue: The museum pieces. Today, surviving panthers and tigers sit in military museums around the world. They look impressive, massive, powerful, menacing. Museum visitors admire their thick armor and long guns. Tour guides discuss their tactical superiority over Allied tanks. What the museum placards rarely mention is that these tanks spent more time broken down than fighting, that their impressive capabilities were theoretical rather than practical. That a Panther might dominate a Sherman in a one-on-one duel, but such duels were fantasy. Real war was about availability, logistics, and keeping your vehicles running day after day, week after week, month after month. The few Panthers that survived the war did so partly because they broke down before they could be destroyed in combat. Many were captured while immobilized, waiting for repairs that never came. Others were abandoned by crews who recognized that without parts, without tools, without time, their sophisticated tanks were just expensive obstacles blocking their retreat. Veterans sometimes visit these museums. Former tankers who drove Shermans through France and Germany occasionally stand before a Panther and remember. They remember the fear they felt when one of these tanks appeared on the battlefield, but they also remember seeing them abandoned on roadsides, tracks frozen, engines silent, crews long gone. One veteran, interviewed at the National Armor and Cavalry Museum in Fort Moore, Georgia, stood before a beautifully restored Panther and shared his thoughts. "She's pretty. I'll give her that. But pretty doesn't win wars. My Sherman wasn't pretty. She was loud, she was uncomfortable, she smoked like a chimney when she started up cold. But every morning, she started. Every time I needed her, she ran. When she broke, and she did break, my crew could fix her and get back in the fight. That Panther there? Beautiful tank." But her crew probably spent half the war waiting for her to be fixed. The lessons remembered and forgotten. The maintenance lessons of World War II armored warfare seemed clear and unambiguous in 1945. American military planners wrote extensive reports documenting how German tank complexity had proven to be a strategic liability. The consensus was unanimous. Future American tanks would prioritize reliability and maintainability alongside combat performance. For several decades, this lesson held. The M46, M47, M48, and M60 tanks all reflected the World War II maintenance philosophy. They were designed to be serviceable under field conditions by soldiers with standard tools and reasonable training. When the M1 Abrams was developed in the 1972nd, maintainability remained a core requirement. Despite its sophisticated systems, the Abrams was engineered so that major components could be swapped quickly in the field. But institutional memory fades, and each generation must relearn old lessons. By the 1992nd and 2000s, as American military technology became increasingly sophisticated, some of the World War II maintenance wisdom began to erode. New weapon systems, from aircraft to armored vehicles to communications equipment, became more complex, more computerized, more dependent on specialized diagnostics and proprietary components. The maintenance burden began to increase. Modern American tanks require more maintenance hours per operational hour than their predecessors. The M1 Abrams, despite its modular design, needs sophisticated diagnostic equipment that wouldn't have been recognized by Sergeant Thompson or Corporal Martinez. The Bradley fighting vehicle, the Stryker, modern artillery systems all require more specialized maintenance than their simpler ancestors. This trend concerns some military logistics experts who study the World War II experience. They warn that complexity has costs that don't appear on procurement spreadsheets. A weapon system might perform brilliantly in testing, but if it requires 10 hours of maintenance for every hour of operation, if it needs specialized parts that take weeks to arrive, if it can only be serviced by factory-trained technicians with proprietary diagnostic computers, then it risks repeating the German mistakes of 1944–45. The debate continues today. Some argue that modern technology, properly implemented, can be both sophisticated and maintainable. They point to diagnostic systems that pinpoint problems quickly, to modular components that can be swapped rather than repaired, to improved reliability that reduces maintenance requirements overall. Others argue that we're drifting toward the German model, exquisite systems that work brilliantly when they work, but which impose crushing logistics burdens when operations extend beyond ideal conditions. They warn that in a major conflict against a peer adversary, the kind of grinding, attritional war that World War II became maintenance capacity will matter as much as firepower. The truth, as usual, lies somewhere between. Modern weapon systems are more reliable than World War II equivalents in absolute terms. A modern tank won't throw a track as often as a Sherman. Its engine won't fail as frequently as even the reliable Continental Radial. But when problems do occur, they're often more complex to diagnose and repair. The trade-offs have shifted, but they haven't disappeared. The wisdom of the wrench turners. If there's a hero in this story, it's not a particular tank or weapon system. It's a philosophy, embodied by men like Captain Houseman, Sergeant Thompson, Corporal Martinez, and thousands of other maintenance personnel who understood that wars are won in workshops as much as on battlefields. These men weren't glamorous. They didn't lead charges or fly combat missions. Most came home without medals or recognition. Their contribution was measured in kept running tanks, in hours shaved off repair times, in field expedient fixes that worked well enough to matter. They understood something that's easy to forget in peacetime. When weapon systems are evaluated in optimal conditions with full maintenance support, complexity is a tax that compounds over time. Every sophisticated system, every specialized component, every proprietary part is a bet that your logistics will hold up under the stress of extended operations. Sometimes that bet pays off. Sometimes it doesn't. The Germans in World War II made sophisticated tanks because they believed the war would be short and they'd have time for proper maintenance. They were wrong on both counts. Their beautiful Panthers and Tigers became expensive anchors, burning resources while sitting broken in workshops. The Americans made simpler tanks because they assumed the war would be long and ugly, fought far from home with stressed supply lines. They were right. Their adequate Shermans, maintainable under primitive conditions, stayed in the fight long enough to matter. There's a quote, often attributed to General George S. Patton, though its provenance is unclear. A good plan violently executed now is better than a perfect plan executed next week. The tank maintenance story suggests a corollary. An adequate tank that runs every day is better than a superior tank that sits in the workshop. The math that mattered. In the end, the maintenance war came down to arithmetic that any soldier could understand. German Panther Battalion, nominal strength, 76 tanks. Average operational availability, 37%. Typical operational strength, 28 tanks. Maintenance hours required per 100 miles, 11.4 hours per tank. Total battalion maintenance burden, 867 hours per 100 miles. Likelihood of major mechanical failure per 100 miles, 23%. American Sherman Battalion, nominal strength, 76 tanks. Average operational availability, 74%. Typical operational strength, 56 tanks. Maintenance hours required per 100 miles, 3.2 hours per tank. Total battalion maintenance burden, 243 hours per 100 miles. Likelihood of major mechanical failure per 100 miles, 7%. The American battalion could field twice as many operational tanks while requiring less than one-third the maintenance effort. Over the course of a month's operations, this advantage compounded. The German battalion would struggle to maintain its already low operational strength. The American battalion would sustain high availability throughout. This wasn't because American mechanics were better. German maintenance personnel were highly skilled. It wasn't because American supply was more generous. Both sides provided adequate parts for their respective systems. It was because American tanks were designed to be maintainable, and German tanks weren't. One final statistic captures the entire story. In 1944-45, the average German Panther spent 63% of its service life in some state of maintenance or repair. The average American Sherman spent 26% of its service life being maintained. The Panther was operationally available 37% of the time. The Sherman was available 74% of the time. Those numbers, 63% versus 26%, 37% versus 74%, represent the difference between a military machine that could sustain operations and one that couldn't. They represent the difference between winning and losing the maintenance war. Conclusion: the unglamorous victory. The story of World War II tank maintenance is not the story we usually tell about the war. We prefer tales of heroic battles, brilliant generals, and technological breakthroughs. The maintenance war offers none of these dramatic elements. It was won by anonymous mechanics working through cold nights to replace a final drive, by logistics officers who ensured parts arrived where needed, by design engineers who understood that simplicity beats sophistication, by procurement officers who chose the adequate and reliable over the impressive and temperamental. Captain Theodore Haussmann returned to civilian life after the war and went back to work at General Motors. He spent the rest of his career designing truck components, transmissions, primarily. Nothing glamorous, but his designs were known for being robust, reliable, and easy to service. His wartime experience had taught him that elegance in engineering isn't about sophistication, it's about appropriate simplicity. Sergeant Raymond Buckley opened a garage in Ohio after the war. He specialized in fixing things other mechanics couldn't, using the diagnostic skills he'd honed keeping Shermans running in combat. He never talked much about the war, but he kept a photo on his workshop wall, him sitting on the fender of his Sherman, somewhere in Germany, 1945. The tank looked battle-worn but operational, still running when it mattered. Sergeant Willie Thompson returned to Louisiana and worked as a diesel mechanic for 40 years. He could diagnose problems by sound, by smell, by the feel of vibrations through the frame. He'd learned to trust his instincts during the war, when proper diagnostic equipment wasn't available. His students, he trained hundreds of mechanics over the years, remember him saying, "Don't build what you can't fix. Don't field what you can't maintain. Complexity is fine if you've got time. In war, you never have time." Corporal Jimmy Martinez went back to Texas and eventually became a technical writer for an aircraft manufacturer. He wrote maintenance manuals, trying to make complex systems understandable to average mechanics. He remembered his frustration trying to repair Panthers with inadequate documentation, and he made it his mission to ensure American mechanics would never face the same problem. These men and thousands like them won the maintenance war. Their contribution wasn't dramatic, but it was decisive. They kept the Allied armies mobile while German forces became progressively immobilized by mechanical failures they couldn't repair quickly enough. The Panthers and Tigers that fill today's museums represent sophisticated engineering applied without adequate consideration for logistics reality. They're beautiful machines, impressive machines, but ultimately impractical machines. They were designed to win battles, not wars. The Shermans, now mostly scrapped or relegated to memorial displays, represent the opposite philosophy. They were designed to keep running, to be fixed quickly, to stay in the fight. They were adequate rather than excellent, but adequacy sustained over time beats excellence that can't be maintained. Wars are not won by the best weapons. Wars are won by weapons that work when needed, where needed, as often as needed. The maintenance war proved this truth more clearly than any battlefield engagement. When American soldiers climbed out of captured Panthers in the spring of 1945, frustrated by yet another mechanical failure requiring hours of complex repairs, they understood something profound. Germany hadn't just lost the technological war or the production war or the strategic war, Germany had lost the sustainability war. They'd built a military machine that couldn't be maintained under realistic conditions, and no amount of tactical brilliance or individual courage could compensate for that fundamental flaw. The wrench had defeated the Panzer. The mechanic with basic tools had triumphed over the sophisticated engineer. The maintainable had conquered the magnificent. And that unglamorous victory, fought in workshops and repair bays rather than battlefields, was as decisive as any won by tanks and guns. Sergeant Thompson put it best in a letter home in May 1945. "We won this war in the motor pool. Nobody will remember us or thank us. That's fine. We know. The tanks rolled because we kept them rolling. That was enough." It was enough indeed. The Allied armies stayed mobile, while German forces became progressively paralyzed. The Maintenance War, invisible to those who didn't fight it, helped decide the outcome of World War II as surely as any famous battle, and the lesson remains relevant today. In any extended conflict, the side that can sustain operations that can keep its equipment running day after day holds an advantage as valuable as any weapon's performance specifications. The magnificent Panthers sit in museums, monuments to sophisticated engineering that failed the practical test of war. The ordinary Shermans, mostly gone now, deserve equal honor not for being the best tanks, but for being the tanks that ran when they needed to run, fought when they needed to fight, and kept running until the war was won. That's the story of the Maintenance War. Unglamorous, unremembered by most, but absolutely essential. The story of how reliability triumphed over performance, how simplicity defeated complexity, and how the humble wrench proved as mighty as the gun. The Germans built tanks to impress. The Americans built tanks to last. In the end, that made all the difference.